All right, guys, this is a little bit of a mini lesson on Unit 6, or I'm sorry, excuse me, Lesson 6. This was one of the warm-ups. You can pause the video and just practice this, and then I'm going to go through each one, and then you can watch the answer. So here you're just saying, when will this equal, what will this equal when x is 10? So if you plug a 10 in, you get 10 times 50 minus 10, which is 400. Um, Same thing goes for these guys. When you plug a 20 in, what do you get? So here you get 600, and oh, excuse me, actually you end up getting 50 minus 20, which is 30, and 30 times that original x, which is 20. I'm sorry, you do get 600. And then here, when you plug in a 30, you get, again, I believe you get a 600. A of x equals 0, so this is saying the y equals 0. So when the function equals 0, it's already in factored form, so you can set each of these equal to 0 and then solve. So x equals 0 is one of the factors. 50 minus x equals 0 is the other factor. So when you solve this one, you get x equals 50. So your two answers are 50 and 0. So this was part of the lesson. This is page, I believe this is page 40, or I'm almost positive this is page 40 in your packet. It talks about at what time does the aircraft reach an altitude of 30,000. So thinking about that there is this plane and it is going to alter its flight plan, and the flight plan is going to actually dip below the maximum, this altitude of 3,000 feet. So you can think of this horizontal line as y being 30,000 feet. And so in order to know when it dips below 30,000 feet and when it's above 30,000 feet, we pretty much need to know the intersections of this linear equation and this quadratic equation. So in order to do that, we take this is our path of the plane, and we want to know when does it reach 30,000. So if we set this equation equal to 30,000, and we have to solve this quadratic because that'll give us the time that this airplane is at exactly 30,000 feet. So I'm going to subtract 30,000 from both sides. And what ends up happening is the c totally cancels out. Now, in order to solve for t, there's two different things that we can do. We could use the quadratic formula, where a is 16, b is negative 500, and c is there is no c, so it's 0. Or I can try to factor. This is actually a pretty easy one to factor because I can see that it's a binomial that has a greatest common factor. And the greatest common factor is a 4t. And when I factor out a 4t, you end up with 4t minus 125. Because I divided each of these parts of the equation by 4t. Now I have it in factored form. I can use the zero product property because both of these factors equal 0. So I can set each one equal to 0, 4t equals 0. And that, when I divide by 4 on both sides, I get time is 0. And the other one, I'm going to solve for 0. I'm sorry, solve the equation, set equal to 0 and solve. Divide by 4, and you end up getting about 31.25. So that means that it hits 30,000 when the time was 0. So pretty much when we started counting, when the airplane first dipped below, we started counting. And then eventually the airplane came back up because it was past the disturbance at 31 and 25 hundredths of a second. So the question is, at what interval is the aircraft below 30,000? So I can see from my picture that it's below between these two times. So I can say that the aircraft is below 30,000 feet when the time is between 0 and 31 and 2500 seconds. So I could also say, when is it above 31,000 30,000 feet, so it's above right here. So after 31 seconds, it's back above. And before 0 seconds, it was back above. Here's another example of that problem. Here is the water level is at a height of 2. So I'm going to draw a horizontal line, and I can write either f of x equals 2 or y equals 2, or I can write the height is 2. And basically, you have a diver that comes down, goes under the water, and then obviously it won't be flying out of the water, but it comes back up above the water at this path. And this is the motion of the diver, and I knew that it was what we consider to be a happy parabola because it's going upwards because it's 1, the dilation is a positive 1 right here. So it says, when does the diver hit the water? So that's going to be right here. So it'd be best if I actually find out when my quadratic equation intersects with my linear equation. So I'm going to set them equal. I'm going to find out when this equation will equal 2 feet. Because that's when since I know that the height of the water is at 2 feet, if I solve this equation, I'm going to be able to figure out when this person hits the water. So again, I'm going to subtract 2 from both sides. You get x squared minus 10x, and if I subtract 2 from 10, you get positive 8, which now equals 0. Well, this is not factorable, so I'm going to have to use the quadratic formula. And I'm going to start the quadratic formula over here. So negative b. So b is negative 10, c is positive 8, and a is 1. So negative b ends up being positive 10 because it was minus a negative, plus or minus the square root of b squared, which is 100, minus 4 times a, which is 1, times c, which is 8, all over 2 times 1, which is 2. Negative 4 times 1 times 8 is negative 32, so 100 minus 32 is square root of 68, which does not go in even. You'll get a whole number. So I have 10 plus or minus the square root of 68 divided by 2. When I do 10 plus the square root of 68 divided by 2, I get one answer. 10 minus the square root of 68, I get another answer. If you do that on your calculator, so here is 10 plus root 68. Enter, divided by 2. You get about 9 1/10, or about 9 seconds, 9.1 seconds. And then 10 minus divided by 2. You get 0.88. So 9.1 and 0.88. So let me go ahead and go back into my equation. And let's write those in so that I kind of understand what that means. This is the x. So this is the number of seconds it takes the diver to go from wherever he was diving or she was diving from to the water. Then eventually, when they get back out of the water, that was at 9.1 seconds. So when does the diver hit the water? Well, the diver hit the water after about 0.9 seconds, a little less than 1 second. At what time interval is the diver underwater? Well, the diver's underwater pretty much all down here. So that's going to be when the time is between, 8.8 seconds or 0.88 seconds, 88 hundredths, and 9 1/10 seconds. So that would answer the second question. We're going to go ahead and do one more, but I want you to try to practice this one on your own. So read the problem, and then when you're done reading the problem, see if you can actually pause the video, solve it, and then watch as I solve it. So someone throws a sharp object in the air with this motion. So I can see with the negative x squared, the sharp object's going like this. Miss Stewart flies at the object in a linear motion. So Miss Stewart's coming this way. And you can see that Miss Stewart might be able to grab the object 2 times. When it's on the way up, or she can grab it when it's on the way down. Okay, so will Superwoman get to the object? So we know she'll get to the object if she actually intersects with the object. If we find out that the drawing looks like this, then Miss Stewart never reaches this line if there's no intersection. So what we can do to solve this is set these equals. See if they intersect. So 3x minus 5 equals, so I'm going to solve, because it's a quadratic, I want to get it equal to 0. So I'm going to subtract 3x on both sides. And 8x minus 3x is 5x. And then I'm going to add 5 on both sides to get rid of the 5. So I end up with 0 equals x squared plus 5x. And remember, I added 5 on both sides, which will get me positive 3. This is not factorable, so I'm going to have to use the quadratic formula. Negative b, negative 5, plus or minus. Square root of b squared, so 5 squared is 25, minus 4 times a times c. Excuse me. All over 2 times 1, which is 2. 4 times 1 times 3 is negative 12, so 25 minus 12 is 13. So I have negative 5 plus or minus the square root of 13 over 2. So let me do both those. Negative 5 plus the square root of 13 divided by 2. And negative 5 minus the square root of 13 divided by 2. So in this problem, you actually get 2 negative answers. So Miss Stewart actually doesn't get to, this is actually kind of an interesting problem because the way I constructed it, they actually do intersect, but they intersect at negative times. So technically, she doesn't get to it. Normally, if you're doing a problem like this, and I apologize for the messed up problem, if there is an intersection, if we find out that x is 2, 0.2 and 5.6, that would mean at 2.2 seconds and 5.6 seconds, Miss Stewart will actually get to, it'll intersect and she'll be able to grab the sharp object and save the day. But because they're negative, this problem doesn't really make sense. So let's pretend for a second that using the same process, you got these 2 answers. It says at what interval is the object above her flight path? So that would be like saying, when is the knife, when is the knife above, Miss Stewart? So that would be everything over here. So you could say between these 2 times, the knife or the sharp object is above her, and below, less than 2.2 seconds and greater than 5.6 seconds, it's actually below her. Okay. So again, I'm sorry for the messed up problem, but I hope you understand at least the process we use to solve it.